My dear students, today we want to discuss the chapter 3 of the class 12th, which deals with the topic Kirchhoff's junction rule, which is also called the first law or the point rule. This is frequently asked in the exams. Very well, you can score complete marks from this section. Kirchhoff's junction rule, as it is written over here, is dealing with the complicated electrical circuits having lots of junctions, isn't it? The other names, the first law or the point rule, what is this? This junction is same as this point. It is synonymous. Okay, lots of resistances, cells are connected in an electrical circuit, and it will make the thing so complicated that we may get difficulty in finding the current, the potential differences in all these electrical circuits. So we have a certain laws which govern the measuring of this potential difference in the current. So when we are discussing this first law, it is as in the Ncert text, we must discuss in a way that in an electrical circuit at any junction, the sum of the currents entering the junction is equal to the sum of the currents leaving the junction. Okay. In any electrical circuit at any junction, the sum of the currents entering the junction is equal to sum of the currents leaving the junction. And another way we can say that the algebraic sum of the currents at any junction, we can find this. Consider this diagram. This is called the junction. This is the junction where these I1, I2, I3 current meets. This is the junction. And from this junction, these currents will get out through I4, I5, I6, I7, and I8. And it is written algebraic sum of the currents at any junction in a circuit is 0. That means it is represented by this. But look, this makes it so complicated. No, it is written mathematically. I will make it easy for you. Look at this, which I am writing over here. I1 plus I2 plus I3, which is the inward current, which is equal to the outward current, I4, I5, I6, I7, I8. That means, okay, you are all exceeding with all these. Input is equal to output. I can write it here also. When all this plus I4, I5, everything, when will go to the left-hand side of this equality sign, it will become this, no? The input over here and minus I4, minus I5, everything will get into negative. And we can write it in a much more way, a good way, that we can put all this in a bracket and add. Oh, what is this? Everything is added, no? That means the summation. The summation sigma symbol is this. The summation of all this current through the junction is equal to 0. That means the inward current is equal to outward current. But please try to by heart all these signs very correctly. That means that in an electrical circuit, any junction, inward is equal to outward, entering is equal to leaving, or algebraic sum of currents at any junction, 0. Okay. By later on discussion, total current coming toward junction, total current leaving the junction, coming is equal to leaving, junction of several lines. If we see a junction like this, or I will later discuss on this also, we will just apply this point rule. The first rule, the junction rule. Proof. The proof is written in Ncert text like that. No accumulation is at the junction or the point. Consider these three lines which have some resistances also, which is getting over here. And you just want to consider the way that these things be like a river. The first river, second river, third river joins to form to get joined in a junction at a point, and it will flow out. These rivers will flow out after that from the junction, like I4 river, I5 river, I6, I7, I8 river. That is the essence. That means no accumulation at the point of the junction. The rate of current inward flowing. That means what is the rate? The amount of water or the current is flowing through these. The total rate in is equal to total rate out. That is written over here. That means the rate of the current flowing inwards is equal to the rate of the current flowing outwards. This is to be by hearted well so as to score good marks, please. And coming over to the I want to tell you some basics. The basic equation, the voltage is equal to current into the resistance, and current supply source is by the battery. This battery contains electrolyte. Some chemicals are there, zinc, plate, ammonia gel, everything. And there is an external resistance. This external resistance, which will encounter when the current flows through the circuit, will get into the negative side. And inside this cell, there is a small resistance offered by this electrolyte. So, which is denoted by the small r, the internal resistance R. Okay, so the electromotive force, which is represented by this epsilon, which is represented over here, this is equal to the total potential difference plus this internal resistance contribution into the current flowing through this. Okay, this is written by the equation, which is given in the box. Okay, when we want to get on to the next law, we want to get a general idea of what will be the real situation of how a circuit will look. Look, this is a circuit which is having a cell which is having 80 watt over here and a 45 watt over here. Can we discuss the flows through the mesh? So this I3 current, let me name it. Naming I3, which is split into two. That means I3 is equal to I2 plus I1. And the same I1 will pass through this whole area, this whole line, will get into this junction, isn't it? This I1 over here. This I2 will also flow through this section, come over here. So first I consider I3 is equal to I1 plus I2. You must answer this. That means at another junction they will meet. I1 plus I2 gives the same I3. That means something this I3 will give rise to somewhat I1 and I2 over here. The same I1 and I2 will come to form the I3. So the rate of current both joining together I1 and I2 is equal to rate of the current through I3. And the amount of current I3 is equal to amount of current I1 plus I2. And what all we have given in the law, it is same all over applied at here. This point A point and the D point. Okay, by now you have learned how to identify a junction and name the current accordingly according to your conveniences. Bye. See you in the next class. If you have any doubts, please contact me. I will be very happy to clear all your doubts. What all I am saying, study it very clearly. It will benefit you in a way so that you can understand it in the light, simplest way possible. Bye.